Hello again. We're working with double angle formulas for the sine, the cosine, and the tangent. Basically, sine of 2 theta has one specific formula. The cosine double formula has 3 different options to choose, and tangent has 1. When I give this problem to my students, it depends on what we're working on specifically. But it's not terrible, it's not too bad. I'm going to go ahead and try to prove it really quickly, or not prove it, but show you that it works, and see how it goes. So I'm going to try one of these, and the one that I like trying the best for my students is this one, this first one of the cosine of 2 theta. And I pick a value that students know that they're working with. And you can use this for a multitude of problems. You can actually use this later for trig identities, like if you want to turn sine of 2 theta into something with a cosine, there you go. Or if you want to turn something with cosine 2 theta into only something with a sine, there you go. It has its interesting points, and the more acclimated you become with identities, the better it is. We haven't really touched on that subject, but there's a million different problems you could do with that, and I don't have time to do a million different problems. So I want to go ahead and do this really quickly. And I want to pick something that's easy to do. I want to do the cosine of 90 degrees. But what I'm going to do is I'm going to say, okay, using this formula, what's the cosine of 90 degrees? Well, it's 2 times 45 degrees. That's going to give me cosine of 90. I'm going to use this one right here, sorry, this one. I'm going to go ahead and I'm going to plug in what I know. Cosine, and my theta is actually 45 degrees, and I square it, plus, minus sine 45 degrees squared. And it should be noted that when you see cosine squared of theta or sine squared of theta, it just means cosine of 45 squared, sine of 45 squared. Another way to say this is cosine of theta times cosine of theta. Another way to say this is negative sine of theta times sine of theta. So I'm just going to put the square on the outside as opposed to on the inside. Now the cosine of 2 times 45 is the cosine of 90 degrees. We'll figure out what that's equal to in a second. Equals the cosine of 45 degrees. Well, the cosine of 45 degrees is root 2 over 2. But it's squared. And I'm going to subtract it by the sine of 45 degrees. And the sine of 45 degrees is also root 2 over 2. It's its cofunction and it's a complementary angle. Therefore, it's the same exact value. And that's squared. Well, the cosine of 90 degrees is 0. And I've said this before and I'll say it again. You have to know what 30, 45, 60, 90, 0, 180, 270, and 360 are of cosine, sine, and tangent. It's just something you have to memorize at that point. Now a lot of students say, well, my teacher can't. No, did you take the time to memorize it? Because if you don't take the time to memorize it, it's incredibly difficult to teach. Okay, so this is square root of 2 over 2 squared. Square root of 2 squared is 2 over 2 squared, which is 4. Subtracted by square root of 2 squared is 2 over 4. 2 fourths minus 2 fourths is 0. And there you go. Everybody already knows what the cosine, well, not everybody, but people who study trig for a while and have actually gotten to this point of double angle formulas knows what the cosine of 90 degrees is. So you don't really need this formula in order to figure it out, but it's just a cool way to show it. You can also use this with actual spots on the actual unit circle itself. We haven't really explored that, and that's fine. I'm not terribly acclimated with, well, not acclimated, I'm not terribly interested in really doing that at this point. But there you go. You can go ahead and plug them in. Whatever your specific theta is, use it into double angle formulas. It's a short, brief tutorial on it, but hopefully it helps. With that said, I hope you have a good day. Goodbye.